don't know, I'm not used to that. And I was teaching a stats class, and about halfway through the class, I put my water bottle down right in front of it, and I was like, I totally forgot about it. So watching the video, you can hear me, but all you can see is this. It's a useful video, Jeff. Thanks.
But at least we hear the explanation, you know?
Yeah, exactly. All right. So what we didn't do in chapter 3, there's actually two things. One of them, I don't think we did this one yet. Section 3.5, the word problems with 3 variables. Section 3.5. I don't think we did that one yet.
Solving application.
The best way to do that is just to jump into it and try a couple of them out.
Oh, yeah.
So look at number, well, let's look at one of these silly ones here real quick. Number 2, page 235. I call 2 a silly one because it's really just exactly one step away from a pure math problem. There's no Fred making some money here. This is just, these numbers do this. So I really just got to write the equations down. The sum of 3 numbers is 5. What would that equation look like?
X plus y plus z
I like
equals 5.
X plus y plus z equals 5. You could use A, B, and C. You could, if you have a 3-letter name, Tom, you can use T, O, and M, whatever. I don't care. As long as there's 3 variables up there. So that's from relationship 1 is 3 numbers add the 5. There it is. The second thing they tell me is the first number minus the second plus the third is 1. So the first number minus the second plus the third is 1. And you see how writing that first equation, you sort of put them in places, so now you can directly translate from what they said. And then finally, they say the first one minus the third. So the first one minus the third, what would that be?
X minus z.
Good. The first one minus the third one is 3 more than the second.
3 what?
Y plus 3, or 3 plus y, doesn't matter in that case. The one to be careful about is like if they said 3 less than x. How do you write 3 less than x?
X minus 3.
X minus 3. If you write it the wrong way around, you're going to get negative side links for building something. It's freaky, right? So that's the most common mistake. If you get negative answers for the age of a bunny rabbit, that's freaky, or some, whatever the hell the problem is, you probably turn something the wrong way around, and it's normally the less than problem. Now you just start attacking this like normal. What's the one thing up here that's kind of like in the wrong, wrongly organized? Yeah, the third one's kind of a little wrong. What's in the wrong place?
Y.
So I can just move that y over, right? X minus y minus z. Now that looks more like, and that's relatively easy one. Do you guys see that? All the freaking coefficients are 1. So as long as there's a single, at least one of them that's negative, it would be really easy to do the y's, wouldn't it? Because you add these two, you add these two, it dies. You got your 2 equations in x and z, right? You guys see that? Normally, these word problems set themselves up a lot easier than word problems that we're used to, like, you know, one train leaves Wyoming going south, and then, you know. These set themselves up a lot easier. That one definitely was too easy. Let's look at one that's a little bit harder. Number 5. Are you guys okay with me not solving that? Can you guys solve that?
Yeah.
Setting it up is the semi-hard part here. So just to save time, we're just going to set some of these up. Look at number 5. This one I might want to solve, though, because it gets a little, well, let me see, is it really? Yeah, this one might be a little bit freaky.
Good look at those Z's and
This one, see how, this is exactly what I mean by they set themselves up. What's one equation? They're from the very first sentence.
B equals 3A.
Yeah, B is 3 times that of A. So B is 3A. What about the second thing they tell me? Angle C is 20 more than A.
C equals A plus 20.
C equals A plus 20. You can't beat that for easy. What, now how many letters do I have up there so far?
3.
And how many equations do I have? Do they tell me anything else?
Yes.
What do they tell me?
It's a triangle.
I like it.
Plus B plus
They
C
tell me
plus
it's a
D.
triangle. So they do tell me something. They tell me that A plus B plus C must be 180. Beautiful. Cool. So don't forget that. I mean, if you're talking about angles of a triangle, you got to be real careful. In the background, there is something they're telling you. They're telling you that. Now, this is set up to make it actually easier than I thought it would be. You can solve this. You can solve the system differently than we have to solve this one. Because aren't there a lot of letters already missing? The really nice thing about this one is the correct letters are missing. And what I mean by that, and once you see this, you start looking for this. B is 3A. C is A plus 20. A plus B, well, B is this. Plus C, well, C is that. So if you substitute twice, you end up with an equation that only has A in it. So you can solve for A. So if I'm missing letters, I hope to God that'll work. If they would have put a B here, then it would have been a little bit different. Right? It still wouldn't be that bad, but it wouldn't be quite as easy. So you hope to God, you're like, oh, hopefully one letter and another letter, they're both related to the same letter, because then I can just substitute in. So how can I rewrite number 3? A plus B, well, B is this, plus C, well, C is that. Once I get A, don't I have B? Just triple it, add 20 to it, and I got C. I'm done. So you would think that always, if I was missing letters, it would make it easier. No. If the wrong letters are missing, it actually makes it a little bit freakier. Okay. If you really wanted to, you could subtract this over, subtract the A over, and attack it like normal. You really could. That would take longer, right? But it would work. So then you get 5A, subtract 20. So A equals
32.
32, I like 32 degrees. So B equals,
96,
sweet, just multiply that by 3. And C equals
52.
52 degrees. How do you check yourself? Add them up and see if they equal 180 like they're supposed to. I like it. That was nice. Don't get too optimistic. They're not going to have a lot like that. Let's do one that's a little bit freakier. Let's see. So may have the homework list. I didn't see if I assigned you a certain type of problem. Can't remember now. Oh, I did 3 through 12. Yeah, so I did. Oh, that's better than I thought. Okay. Yeah, I only gave you 3 through 12, right?
Mm-hmm.
All right. I went nice and easy on you, so enjoy that. Look at number 9, for example. We're not even going to really set this up. Let's see if you guys can see what one of the equations would be. Number 9 says most nutritionists agree that you need blah, blah, blah amount of fiber. A breakfast of 2 bran muffins, 1 banana, and 1 cup of Wheaties contains 9 grams of fiber. So let me say that again. 2 bran muffins.
1 banana.
So can you start to put together an equation? 2 bran muffins. So what letter do you think you want to use? 2M. You don't want to use B because you got bananas too, right?
Yeah.
So 2 bran muffins. So 2 muffins, 1 banana, and 1 thing of Wheaties.
1 W.
Gives you 9 grams. I mean, do you see how that sets itself up? Stupid nice. Just use the same letters from the words they use, right? It would be really evil if it said you had shoes and shoelaces and suntan lotion, SSN. Oh crap, you got to come up with, some letter, but it's still not that bad.
By
Yeah.
the way, when we have to do that, and it's not obvious, we should put the legend for you, right?
Yes, please, dear God. That would be
Yeah.
helpful.
I had a teacher once.
Don't just have A's and B's on every single problem, and I have no idea. It's not always apples and bananas, so A and B won't always work. If there's a problem like this, I know that means muffins, bananas, and Wheaties. You don't have to tell me necessarily, but always default to give me a legend. Like X equals the amount of whatever, saline.
Roman, Iowa.
Yeah. Is that section okay? I mean, let me give you guys one to try on your own. And try to work it all the way through. This would be a good review of matrices. Let's see. Oh, this is a good one. This is a little bit freaky. Try and do number 8. So you got to read it maybe a couple times to make sure you pick up on what the variables really are, and then give them appropriate letters. And I do have the answer key for that practice test, so if you have to head out early or something, make sure you grab that before you head out. Oh, yeah. Okay. Yeah. Oh, that's right. It's amazing. I don't understand. Yeah. Yeah. Oh, yeah. Yeah, I designed it and take a lot less. I'm hoping to God people before it's 3 hours, 50 minutes have passed. Okay. Oh, yeah. I'm with you. Mm-hmm. Yeah. Gotcha. Okay. Oh, cool. Okay. Oh, sure. Yeah. So you just put the corrected up here now. Corrected on the back.
What do you want us to, why did you during the test? I had it on stuff. You just didn't know where it was lost. So I put it.
Oh, that's what that meant.
Yeah.
Oh, say, so yeah, then
So
like
next
work
time.
on the back. Yeah.
Okay. That's what
Might put a little note for myself.
And then what do you want us to do for the corrected two items, like on different pieces of paper and one in that case? That's what I was wondering. Because you said like you could always correct with this, but you never said like the process, like.
Oh, I'll talk about it in general. Real quick, guys, the quiz you just got back today and the other quiz you got back last week, you can do corrections on them on another sheet of paper or on the back of that quiz. Just do not, hopefully this hasn't already happened, don't ever erase original work and replace it. I need to leave that original work alone and then correct it on the back or another sheet of paper.
If you skip the problem, can you just answer it on the paper?
Yeah, anything you lost points for,
Okay.
you can correct, yeah. Which one I said 8. Yeah, good. Just make sure, and then write up here corrected, because otherwise I won't even know to look for you. Cool. All right, guys, let me start to catch up to you. What were your variables in this one? So you said A, that's the 35 to 39-year-old adult.
Right.
S was spouse.
And C is child.
C was kid, children.
Children. Kid.
Children. Yeah, C for kid, exactly. This is why I teach K-A-T-K. So the very first thing I tell you, it's $160 a month for an adult and a spouse. So what would that equation be? 160. 145 for an adult and a kid and a child. What was it now? 145? Yeah. And 245 for an adult and a spouse and a child. Where'd it go? 245. All right, so you guys got that okay, right? So the funny thing is, normally word problems, it's the hard part, and the easy part is solving them. I think in this case it might be a little reversed, because we're still getting used to these three equations with three unknowns. What can I do with this that's related to something we already did? It's just not written in a way that I can see it here. Let me see.
For equations 1 and 2, I solved for S and C, and then substitute that.
I like it. So it's just like this problem, except see how they already solved for B and C here in terms of A? So here, if I solve for S and I solve for C, I can replace them and have just like over there. If you don't see that, what could you do? Did anybody try to do it a different way?
You can multiply 1 by -1 and then add 1 and 3.
Okay, multiply this by -1 and then add 1 and 3, and that'll kill the A and the S.
Yeah.
And then you'll know what C is. I like it. Cool. You guys with me on that? So once you know C, then you know A. Once you know A, then you know S. Cool. So those are two beautiful ways, and that's why when there's letters missing, it all depends on exactly which letters are missing. Sometimes it makes it really quick and easy. Sometimes it makes it where you got to be careful. You don't start killing one, but then making another one start to live again. It's for you to fill in a blank spot. I don't know if you guys quite see what I'm saying, but which way you want to? Let's see. I don't know. Let's try it. We already did one like that. Let's do it the other way. If I do take 1 and multiply it by -1 and add it to 3, I get -A minus S is -160. A plus S plus C is 245. These guys die. C equals 85.
That's really unique.
And once you got C, so it's $85 a month, right? Dollars. So $85. So now you can plug it into 2 and come up with A, and once you get A, you can get S. That's awesome, right? So in 2, A plus C, but C is 85. So A is 60. And if I take and put into 1, 60 plus S is 160, so S would be $100
There's your answer.
a month. Coolness. So just want you to be careful about, don't always try the same exact tactic, the same recipe like that on the handout. If there's letters missing, there more than likely is a quicker way to get there than to just attack it like normal. Okay, and of course, how do you check that? Add them all together and make sure it's equal to 245. Yeah, you can just start plugging them in and make sure that the equations work. Cool. Okay. So that section is word problems, but they're nowhere near as ugly word problems as what you're used to. They're not trains leaving somewhere. There's not building a pen where one side is on a building, so you don't need fins. They're not those kind of problems. They're a lot more directly translatable. Okay. Maybe. So just remind you guys, I'm going to talk about 3-6 now. Actually, I think I'm going to do a little bit in the calculator first before we get into a new thing. I want to show you, I don't think we graphed anything last time we looked at the calculator.
No.
Which obviously is a key thing, because it's in the title of the calculator. How many people don't have a graphing calculator yet? Not too bad. I think I'll be okay. Just kind of look on with somebody near you. So I don't have to run back to the print shop and grab my bag.
Can't use it during the test.
Does this thing
No.
function the same for what we're doing right now?
Yes. Cool. Real quick word too, I haven't had a chance to sit down and compare the names of the people who have taken the quizzes versus the names of people who are actually in my class. I know there's a few people that still need to add because you missed out on the ad code before it expired. So if you still need to add and you are a person that I said could come into my class, then you get a green card from the admissions and give me to sign off on it, right? Please, dear God, if I never said you could be in my class and you try to get me in to get into my class, this is not good, right? You will anger Jeff. This is not good.
Is that good?
Okay, cool.
Which is that?
That's fine. I think you guys can see, right?
Is
You
that
guys
good?
can- Thanks,
Is that-
Jeff. So I'm just going to go over a couple of graphing basics.
By the way, the rules for the 84 and the 83 are the same?
Same.
Okay, good.
Those are exactly the same. The 82 might have a few things look different, but it's got the same graphing procedures. Yeah, if you have an 82. There you go. All right, so if I have an equation I want to graph, and it's got to be a function that I want to graph, and let me see why that might be true. If you have an equation like an equation of a line, so can somebody tell me what the equation of a line would be if I wanted slope to be 1/3 and for it to go through 6 on the y-axis?
X
Y equals
1/3 x
1/3
plus-
x.
Y, I'm sorry.
I like it. So y equals 1/3 x plus 6. Cool? You guys with me? So 1/3 would be the slope, 6 would be the y-intercept. So obviously, which button on here seems to be a good place to go to get that in?
Y.
Y equals, yeah. So way up here in this corner, that'd be so cool whenever I'm able to hit that button and actually do it, but y equals right there, someday. So hit the y equals and let's see what's in there. So if you're borrowing a calculator, or you've checked it out or something, you might have all kinds of crap in there, I don't know. Clear everything if you have stuff in there. Just go to it. If you have stuff in there, like you have stuff down here, like a minus sign, just go down to it and hit clear. I think if you keep going, there's even more off the screen.
Where is it all clear?
There isn't.
There is
Oh,
one.
there isn't, okay, so you have to just keep going up or down.
Yeah. Okay. Does anybody, real quick question, everybody has Y's here, right? Does anybody have a different letter? Because there could be like an R here, believe it or not. Okay, everybody's got Y's. Never hesitate when I'm doing something on the calculator to stop me if you're having freaky things happen. I don't want to bulldoze you. Everybody's got Y's, right? Anybody have something other than this little line here next to them? Okay, good, good. Because there are little programs you can download that might change the look of these. All right, guys, so make sure we're all on the same page. Now let's try this out. What did we just say? We said 1/3 x. Here's your x button right there. You see your x button right there?
What do you third?
Just 1 divided by 3. So 1/3 x. How are we doing?
Cool.
X is right here. Right here. Here's your X button. Right next to your alpha button is your X button. Do you see it's got other stuff? T, theta, N?
Yeah.
You didn't even know that was theta maybe right there. Greek. It's just your general purpose variable button. And
So what do you keep hitting it to change it?
no, you change the mode of your calculator.
Oh, then we don't have to worry.
No. Real quick word on that though. How do we find points in this class? Don't we say, okay, go over this much and up or down, this will be right?
Rise
X
down.
and Y. Another way to find a point is to say, okay, turn this much and then go out this far. Can't I find any point then? So I have a point there, and I want to say, okay, turn this much and go out this far.
Yeah.
That would be just like a circle. Wouldn't it be like the turning would be an angle.
Radius.
That's the Greek letter theta is your angle. And then the radius would be how far you want to go out. That's what's called a different coordinate system, because we're used to Cartesian coordinates or rectangular coordinates, x, y. But you can believe me, there are billions. Now I feel like Carslake. Billions of other coordinate systems. Don't freak out too much. We're only going to talk about x, y, and at most z, right?
Just lost half the
Oh, no. 1/3 x plus 6, right? How does it know this is not 1/3x?
Order of operations.
Order operations, right? You would do it as it comes. Divide the 3 and then multiply by x. If you want to be really careful, you can put the 1/3 in parentheses, but you don't have to, right? Because it knows order operations. So if I graph this bad boy, we know what it should look like. It should start at 6 and it should go, like that from there, right?
So you hit graph?
Hit graph, I love it. Now, we're not all going to look the same, so don't freak out. Okay.
Ooh,
That's what mine looks like.
that's what mine.
Most of yours probably doesn't look like that.
It doesn't. Mine says invalid dim.
Real quick, anybody else get an error of any type? What's it say?
Quit.
Yeah.
Does it say syntax?
Nope, it says window range.
Oh, window range, okay.
Yeah.
That one's easy to take care of. Yours says invalid dim. Anybody else says that? But it did something, right? It didn't show any line? Okay, don't worry. Okay, invalid dim. Yours is heartbeat.
Old school.
That is awesome.
He's just going.
Why is that?
Spinning around motors.
It's like 10 years old.
Any damn sense? Wait a minute.
How'd you do that?
Make a scene.
Sorry, guys. I see
I think it needs an update.
well, there it is. That is freaky. Now that I didn't know. For some reason, the 82 needs that. See that?
Probably not.
It must not know order operations as well. Yeah. Poor little dude. All right, now real quick. Those of you that say invalid dim, if you say invalid dim, what that means is, remember when we put in the list? Remember that we went into list under statistics and we put in L's once and we put in L2. Whenever it says invalid dim, it's trying to graph those, and they're not the same length, so it's missing a part of a point. Right? It's trying to graph the points, and it says I'm missing a point somewhere. So what you want to do is this. You want to go up second y equals, and you get to something like this. This is only for those people that have the invalid dim
Do you gotta clear it first?
error. No. It's second y equals, and you should get to this menu, right? Who else had the invalid dim, right? Okay. Go down to number 4, see?
Mine
Or just
didn't-
hit the number 4 to turn the plots off.
Mine didn't do that. You said press second and then
Second,
press y equals,
y equals, yeah.
and it's staying on that screen.
Your calculator just likes to give us trouble. Oh, that's right, you gotta quit first.
So you do-
And then, yeah, my bad. I thought you'd already, get out of the error and then go to second y equals, you got to there?
Mm-hmm.
Hit number 4. Calculator, hello. Aw. There he is. So then it should come up on the screen, plots off, and hit enter, and it'll say done. So now it's not going to try to plot those points that were put into the lists. Yeah.
So we need to remember then, if we did anything with a list like that, we gotta clean that list out first.
No. It'll only have a mistake if you've got it set to try to plot them. Most of us shouldn't have that.
Okay, good.
If you have a friend that was in statistics, your calculator might need a little working on just to undo the stats setup. But it sounds like most of you guys are okay with that. Some of you guys, you probably have very different looking graphs, right? And you've got the weird window thing. This will take care of that too. Look at this, the zoom button. The most important button besides y equals when graphing is zoom 6. It will bring you back to a standard -10 to 10, -10 to 10. So that you always start off in the same place. Because the minute you start moving and looking around, because maybe you're going to graph something that's like way up there. You want to move and look at it, right? And we'll talk about how to move the window around. But that means that if you plot something over here, you're not going to be able to see the damn thing. You're looking over there, and it's over here. So if you hit zoom And look at all the shit in here.
And then number 6.
Number 6 is Zoom Standard. That's the most used Zoom one, Zoom 6. And now we should all look like this. Hit Zoom 6, all of us should look just like that. So let me know if that's not true.
Mine's lower. Does that matter?
It looks the same.
Oh, hit the Y equals again?
The Y equals.
Yeah, did you put the plus 6 in?
Oh, I did.
Okay. Because right now your Y intercept is 0, it's got to be up at 6, yeah. How's everybody else? Everybody else has that? Alright, and those of you who have used this before, just hang out. This is all old news. Awesome. Just stare at the wall or something. Do we see what we're supposed to see here?
Yep.
The Y intercept is 6, and it goes up 1 over 3. You see that? I could be smart and do this.
And why did you say we have to press Zoom 6 again?
Ooh, there we go. Real quick, so it goes, starts here, it goes up 1 over 3. Do you see that?
Mm-hmm.
So it does exactly. Zoom 6 brings it to negative 10 to 10, negative 10 to 10.
So back to normal.
So you can always start at home base,
Okay.
right? If you hit Zoom 6, you might not see it, but that's maybe because it was too high. If I would have made this plus 80, I wouldn't have been able to see this line. Because it's way the hell up at 80, right?
And you have to press Zoom 20 or something.
We'll see. Let's try that next. Is everybody cool with this? So you can start, you should start playing around with this damn thing. You may be not as big of a geek as me. When I was a little kid, somebody got a calculator, I start just, I'm like, let me see your calculator. Well, my mom's like, thank God, don't have to get him any PlayStation shit. Just give him a calculator and let him sit in the corner.
Give 'em a juicy juice.
If we go back to Y equals, let's go ahead and make it plus 80. 1/3 x.
How do you go back?
Oh, hit Y equals.
Or just the Y equals?
And now you can kind of arrow over so you can edit this thing. Make it, so arrow over to the 6 and just override it with 80.
Oh, I cleared the whole thing.
Okay, put it back in.
How do you clear just one item?
You either hit delete or you just write over it.
Oh, you don't hit clear?
Don't hit clear because that will clear the whole line, yeah.
So now I gotta do
I never noticed that delete button.
Oh yeah, the delete button. On top of that is the insert button. If you want to insert something just like on a, I almost said a typewriter. Wow. You guys remember, does anybody, have you ever heard of those? They're in the archive somewhere. What's this thing? Now, like I said, if you hit graph, what do you see? Not a damn thing, right? And that's because it's way the hell up at 80. So you either have to kind of have an idea where your graph is about. And we do this time, but then I'll do another graph that we don't even know, and I'll show you where to look to see where the hell is the damn thing, right? So there's a couple options actually. Let's try, first I want to show you how to do the window.
Okay, so zoom.
Am I going at decent pace? Is everybody with me?
Mm-hmm.
Hit the window button right there next to zoom.
Oh, window.
So this is like a window on the plane, right? And how big is a XY plane? How big is it?
80.
No, how big is the XY plane?
10, 10.
Infinitely big. So of course my little calculator is not infinitely big, so I can only look at it, I'm looking through a window. And right now I'm looking through a window and the graph is up there. So what do I want to really have happen? I can only see up to 10 right now. So I want to see up to, so if you hit window, you'll see why that's true. The minimum x is negative 10, the maximum x is 10. So from negative 10 to 10.
So we can change that.
The minimum y is negative 10, the maximum y, so at the very least I want to change the maximum y, right?
I'm gonna add
I don't even want to make it 80, I want to make it maybe 90 at least.
I made it 100.
I like it. So I'm going to make mine 95,
Yeah.
Now real quick, the scale is just how often the tick marks show up. So let me show you. If you just change that to 90 or 95 or 100 or something and you hit graph, now I can see it. It's way the hell up there. But notice how these are just so densely packed. So if that's a problem for you, if you don't like that, you can go to window again. Does everybody see this right now?
Mm-hmm.
You can go to window and change the scale.
Holy cow, mine's a straight line.
So like 10, I like it. 10 will be good. See, now you only see a tick mark every 10, 20, 30, 40. Do you see that? Yeah.
Mine came out as perfectly straight line.
It should have a little bit of a kink in there.
No, don't kick it off.
Oh, you got the droid. Maybe it's not got a big enough window. Let me see it. That's because you changed your X and Y. Your X is 6.
Did
You
it
haven't
all.
changed those.
So I gotta reapply. You made it smaller. What should I change? The X is leave at 10?
Yeah, I'd leave them, the X is at 10. And I would leave the Y man at 10. Right? Negative 10. So this is related to, like, if I have along here, number of beers you drank the night before, and I have along here the grade on the test the next morning, I want this to maybe be by 10, but I want this to be by 1. Hopefully we're not drinking beers by the tens of beers, right? Like 10 more beers. But that's actually a problem I did in my stats class. I said we graphed the grade you made and the number of beers. We didn't actually do an experiment. We just did a thought process. When it said, go out and drink some the night before the test. We'll see what happens. No. Are we all decent right now? Are we all doing? Yeah.
I can't, when I hit the down button, it's erasing the input. I don't know why it's doing it. Maybe I'm just thinking just that or something. I made it negative 10 again when I go to,
Oh, because I don't know if I've said this yet. Do you notice how there's a minus button and there's a negative button? Right? That minus means subtract. That negative means a negative number. If you want to say negative number, you must use this. So don't say negative 10. That wouldn't. The calculator goes, what the hell? Subtract 10 from what? They had to hardwire it like that so it would work correctly in a few different situations.
Why does two little squares on the screen?
Oh, because you
Sounds
have
like
data.
commas.
You have data in there, yeah. Oh, that's the thing that's in there. The stat plot. It's plotting those points. You just turn that one down. Oh, yeah, you do. Sure. Okay. So everybody hit Zoom 6 real quick. Let's make sure we're all the same. I know we can't see the current one, right? Let's put in a different equation. Let's go to y equals. So everybody hit Zoom 6 so you get this nice blank. So go to y equals, and let's put this equation. Clear this one. So just hit clear, and it clears that one out of the way. Now let's put this one in. Which one? I don't know. Let's do... yeah, okay, let's do 8x squared.
hey, if we were to use this to do those problems, would it work?
Which problems?
A plus S plus C equals 245. And,
How many variables can you put in here, though? 2. And those have 3 variables. The TI-89, I think, is able to handle 3 dimensions.
okay.
Yeah.
So it would work.
If you got that, which you can't use on a test anyway.
Oh.
So let's try this. 8x squared plus 2x plus 30.
Plus what?
Plus 30. So everybody got that? 8x squared plus 2x plus 30. Oh, I'm sorry. Square is either right here. See it? Right there. So you type 8x and then you hit this button. Now put the square on there. Or you can do the 2 to the second power here if you want to. So let me know if you have any trouble getting that in there. Everybody got that one? I like that. Again, if you're having no troubles, you have to have some patience with me because I got to help those guys that are brand new to this thing. Everybody's got it? What happens? Oh, what's up? You're good? Hit graph. And what happens? We shouldn't be seeing anything.
Whoa.
Did you hit Zoom 6 before we did any of this?
No.
Hit Zoom 6 for me real quick. I want everybody to be at the same place.
What's the problem?
Well, it probably saves the last Zoom.
I didn't
bit.
take it out.
No, it doesn't change anything until you do. I try to get everybody to hit Zoom 6.
Oh.
Yeah.
So we just hit Zoom and go down to 6 and hit enter and then,
Cool.
or you guys hit.
Back to your home screen, negative 10 to 10, negative 10 to 10. I'm going to give you a different way. This is a parabola, so it might not be, it's not as obvious. You should know what the y-intercept is, but I just want to give you a general way to find out. If you're not sure where the thing is, you can't see the damn thing, here's a really good place to go to find it. Look over here. See above graph? It says table. Well, let's just hit it and see. Not everybody's going to be the same. Hit second graph, so I get up to table. And it does exactly what you think it would do. It makes an XY table. No, mine looks like that. Yours probably looks different.
Yes.
Some of you guys are going to be the same.
Is that a table or you guys do function together?
No, just hit second graph, because table is above graph. See that? There's table.
Yep, got it.
So hit second graph.
What if it says x equals -4? At the bottom.
Oh, you're okay. You're okay. It won't start at the same place for everybody, but everybody's got something up there, right?
Yes.
Okay. So I could actually scroll around, and it will show me like that. See? Isn't that silly? Some of you guys might be starting to understand that if I ask you to make an XY table, I don't necessarily know where it's coming from. So if you know how to use a table in your graphic calculator, hey.
So if you said, I need 5 points on this line, there you go.
Yeah. Now, if you have a funky table setting, see where it says table set above window? So the window sets up the graph. Above window says table set, that sets up the table, which is above graph. See how there's kind of like an analogy there. So if I hit second window, you should get this kind of thing. See table start? So that's, of course, mine used to be 0 before I started going in. So now it starts at -2. And what the hell does this mean, the second line there? What's that?
Change.
Changing, that's a little triangle. That means the change in the table. The step of the table is 1. That's why I went 0, 1. So you could put a 0.1 there, and then it would go 0, 0.1, 0.2, 0.3. So you get more detail. You guys with me? So if I changed it to 10.5, right? So make it 10 and 0.5. So now if I hit second table, it'll start at 10 and go up by half. How we doing? Sorry. So we go to the table set, so second window to get to table set. And then you can just write up here, start it at, let's go back to table set, let's all start it at 0. Cool? So make it 0, and make it 1 again.
You're not gonna ask us to graph anything, because are you? 2,480?
Well, why is that though? That's because we're looking way down at 10, 11, 12 for inputs, right? What I'm looking for is the turnaround point.
Right.
That's where I really want to find. So if I go back to 0 and 1, right? Table start at 0, change the table by 1, go back to table. What's interesting around this point? If I scroll up a little bit, what's interesting that I see there? Do you kind of see where the turnaround point,
Here the numbers are starting to go up again, and it's...
right?
Yeah.
Do they come down and then it starts to go back up?
Right.
So the turnaround point is somewhere in here maybe,
Right.
right? Well, actually, maybe in here, right? Because 3630 and then it starts to go back up to 40. It's not symmetric there, is it? So the turnaround point is some weird 0.7 or something. Who knows? Cool.
Why is there a 1? Why 1?
Oh, because if you look at y equals, you can put several equations in. So if you put y2, y3, it'll try to show a few more outputs
But
at
you can't put
once.
several for x.
No, yeah. You
Okay.
can't change the inputs for, it's one input and then it shows you all the outputs.
Okay.
Because I didn't mention that, but you guys see, of course, how under y equals you can put several equations. And of course, the calculator can find intersections between things you put into it, which we'll do here in a minute. But what am I really getting from this right now? Do you get a sense of what I want to change my window to be? The x's are okay, probably, right? But I need to be able to see from
Probably hundreds.
starting, what do I want my y min to be? Do I really want it to be -10?
Oh, no. You want it to be at least like 12, 15.
Well, the lowest here I see is 30, so maybe I want to make it 20 so I can see the bottom. You guys with me? Maybe from 20 up to, not even more than that. 50 will only show me these.
150.
Yeah, 150 or 200 even. Let's make it 200. So go to window.
Window.
The x's are okay. Let's make the y from 20. Enter.
Minus 20, you mean? No.
20.
Oh, 20.
And then 200. and then graph that bad boy.
Oh,
So I left my x's alone, right? They're fine. I don't have to move it left or right. Now I would have to move it left or right if I saw like at x equal 80 is where it kind of bottoms out. I have to make x go up to maybe 70 to 100 or something. You guys see the idea? So if I graph now I'm looking up higher. There it is, right? And then you can do what you need to do with it. Okay. So let me show you one more thing that will help you check your answers on systems of equations. You can never say, I did in the calculator, got this. That's not a valid showing me the work, right? I always have somebody think that means they showed me the work, the buttons they pressed on the calculator. No. So let's kind of reset this thing a little bit. Is everybody cool with that? Do you guys get that on the screen? All right. Oh, before I get too far, there is this, and people always ask me, why don't you just show this first? Because then nobody will care about the window, which is important. But zoom fit, the very last one. So if you go to zoom, and just hit the up arrow.
Zoom.
Another reason I don't show this first is because sometimes it sucks. Well, let's see what it does. Zoom fit.
Zoom.
It does exactly what it says. It tries to fit the graph to the screen, and there it is. So again, I'll do it again. So go to zoom. It's the very last one.
How do you get to the last one? You
Hit the up arrow.
up
Now on yours it might have a few more. I don't know.
0.
Okay. Zoom fit, enter, and then that's what it does. It makes a nice fat parabola.
Yeah, dude.
So it tries to fit the graph to the screen. Alright. So that's always an option also. But I wanted to show you where the table is, because that's important to look at, and how to control the window. Zoom fit's kind of like a shortcut that doesn't always work well. So let's all get this back to normal. How do I get it back to a normal screen?
Zoom 6.
Zoom 6. So now I'm not going to see a damn thing. That's exciting. Now let's put in there, go to hit the y equals, and let's put in an equation, a system of equations, and see if we can get the answer. Oh.
Yeah, so clear everything out.
Let's see. Let's do a nice, easy system of equations. How can I make a system of equations where I already know the answer? Remember, let's start with the answer. Let's say I want the answer to be 2, negative 4, right? So then I can say x plus y equals what?
Negative 2.
Negative 2, right? X plus y, that's equal negative 2. And then let's say maybe 3x minus y would equal what?
10.
10. I like it. So there's my system of equations. We know it's going to have a valid answer. It doesn't even need a valid answer, but I just want to get a nice one that we can do by hand first, and then double check it on the calculator. To do it by hand or the calculator, what do I have to do first?
You have to move it over.
Solve it for y. Yeah.
So y.
So this will be this. Cool. Subtract the x over. And then 2, I could add the y subtracted 10, so I end up with that. Right? So if I want to do this by hand, if I solve for y, I actually could always do this. Negative x minus 2 I could put right there. So negative x minus 2 is what y is, equals 3x minus 10. That's substitution method, right? So then if I add x, add 10, I get 8 equals 4x. X is 2. Remember that's what we had? And of course, y is 3 times that minus 10. 3 times 2 is 6, minus 10 is negative 4. So we get what we're supposed to get. So see how this looks in the calculator. It's exactly what we said it is. Graph one line, graph the other line, it's where they meet. So clear this parabola out of the way. Clear.
Ooh.
What's up? Then put in there negative x. Remember, here's your negative button way at the bottom. Negative x minus 2. So you need the negative button and the minus button for that. And then 3x minus 10, right? There's my two lines. Negative x minus 2 and 3x minus 10. You could also do this, I mean, if I had a parabola in a line, how many places could that line hit it? A couple places it could. Or once, or none at all. But you can graph a parabola, graph a line, and find the intersection the same way we're about to. So you put in the two lines. Now let's try to hit graph and see what we see. Now, do you see how we lucked out? This would be a really good place. If one line was like this and the other line was like this, where do they meet? One line's like this and the other line's like this. They meet down here somewhere. So wouldn't I want to be able to see down? So I go in and make Y min a little less so I can see down further. I mean, that's why the window is important. If you hit zoom fit, it's not going to necessarily make sure you can see this. It's just going to try to fit the two functions on. It doesn't care about the intersection. All right. Yeah.
I used that minus in the brackets twice instead of the minus, and that's what, and I was like, where the heck did the line
All right.
go?
Gotcha.
Yeah, that's really good.
All right. So everybody's got here, right? Now, if you ever want to calculate something graphically, if you look above, now real quick, first off, if you hit trace, it does exactly what it sounds like. It just traces it out. Do you see how if you step around, it shows you the points? Trace is not really good though, because if I try to trace to the answer, can you get exactly the answer? It tries, right? Isn't that close to 2? Isn't that close to -4? But I don't know if the answer is whole number if I'm doing this graph. I can't trust trace. It's close, but I can't trust it to give me exactly the answer, right? So if I want to calculate something, and that's what we want to do, we want to calculate the intersection, go to second trace. So you get up to calculate, right? I think most of what I'm talking about today is on that little graphic calculator handout I gave.
And you're
The first
looking
day.
for 1, which is the value.
So let me go with you. So if you hit second trace, of course, which one do you want?
The value.
Yeah,
The
intercept.
intersection. 5.
1 would tell you, you can plug an X in, it will tell you what the Y value is. So number 1 is if you know the input, it'll tell you the output. What I want right now, notice 0, it would find where it hits the the X-axis, right? Just like in your homework, you had to find the zeros, it's just where it hits the X-axis. Min and max would be good for parabolas. Find the minimum and the maximum, right? But right now, of course, we want intersect. 6 and 7 is calculus. So leave those alone. So number 5, it's going to ask you 3 questions, right? It's going to say, what is your favorite color? What is your quest? Where are my money pythons? Yes, okay. It's not going to ask you that. It's going to ask you, now notice, if you move around right now, you're on a line, right? See that? If I hit the, if I hit the left and right arrows, I move around. If I hit the up or down arrows, I jump from one line to another. So what do you think if there was only one line on the screen, what are the up and down arrows going to do? Nothing. Because there's no other line to jump to. So people get frustrated. Move, move. No, left and right moves. Up and down jumps. Right? So if I hit the up arrow right now, watch it. Pop. It jumped from here to the other line. Right? Okay. So what's the question here? The question is, what's the first curve? And yes, in math, we have straight curves. Just get over it. So what's the first curve? I don't know. Let's call this one the first curve. And it wants to know if I had like 8 graphs on there. It wants me to pick out the 2 that I want to work with, right? So I want to work with this one. Now watch what it does. Hit enter. Look what it automatically did. It jumped to the other one. And the next question is, what's your second curve? So I just have to hit enter. It moved for me. Let me start over again. Because I always have, so it doesn't matter which line. The question is, what's the first equation? Hit enter, because I'm on a line, and it bounces to the next one for me already. Because the next question is, what's your second one you want to work with? Well, that one. Hit enter. And the last question is, what's your guess? And that, the closer you get to it, the easier it is for the calculator to find it. If you are too far away from it, it might never find it. So you put the cursor right on top of the answer. And again, don't do. I always see somebody doing this. It's not going anywhere. No, you got to move left and right. That's about as close as I can get right there, maybe.
And what do you do? Hit enter when you...
Enter for the guess, yeah.
Oh, okay.
And there's the answer there.
Why does it need a guess?
Again, the algorithm that it uses, the procedure it uses, it needs to be fed a guess. And then when it does, it does some calculus, and it gets a better and better guesses until it's close enough, until it's not changing so much it stops. So sometimes you might even get right here, you might get 1.9999999. It's trying to say 2. It just got close enough for the algorithm to go, okay, stop. Right? Are you guys with me on that?
So if you get some out of the park number,
Yeah, if you get like negative 4.0000001, it's trying to say negative 4. It got close enough to stop. You guys kind of with me here? What do you think you get if you get like 1e negative 20? What's e mean on this thing? It means times 10 to the. So what's 1 times 10 to the negative 20? 0.0000. So what's it trying to say? 0. So you see that a lot. You'll see like 7e negative 40. Like, well, shit, that's basically 0. It's trying to say 0. Yeah.
I don't know, mine's just not giving me those words. Like, no matter how many times I hit it, I don't get a word.
Let's do it one more time. So here's the shortcut.
I mean, I'm gonna
Do you remember how it bounced to the next curve automatically?
Enter.
So anytime,
maybe I didn't hit the right thing to get to.
I'll do it again. It's second trace,
Second trace.
number 5. Whenever you're trying to find the intersection, just put the cursor right on the intersection to begin with. And then you hit enter, enter, enter. You hit enter once, it bounces to the next curve right underneath. Enter again, you're already on the guess. So hit enter again, you're golden.
Oh, so we gotta get on the intersection and then hit enter.
Yes, cool. And again, that's all kind of spelled out on that sheet I gave you the first day, the calculator Bible I gave you. You got to play with this though to get used to it. So some of your problems in the homework, some of them will have a little graphing calculator next to it that says use it because this is weird, too weird to try on your own. But I would even try something that you can do by hand. Just double check it, make sure you get the process down. You already know the answer. Try it out on the calculator. Make sure you get the same answer. Okay. Let me think. I think that's enough for that. So I'm going to talk about matrices a little bit. I'll show you in the calculator a little bit. You're not responsible for any of it. It's just if you want to try that bonus question out, if you want to try the homework out, that's going to be extra credit. Cool. And then we'll take a break after that, and then the rest of class time is devoted to pure review, getting ready for the test. Right? Yeah.
Are we finishing chapter 4's homework then for tomorrow?
Chapter 4 homework we'll do Wednesday. To finish out chapter 4, the first 2 sections in 4, which is 4.1 and 4.3, if I remember correctly. Yeah, 4.1 and 4.3. That's what Rick went over last time. Those will be due. Then there's 2 more sections. We will do them after this first test. They'll be on the next test. Does that make sense? You do not have to turn in all of chapter 4 homework tomorrow. Only up to 4.3.
and that will be on the test?
That will be on the test. Cool. All right. So let me turn this off for a minute here. Go on. Stay with me now. All right. Can you bring the lights back up for right now? Can somebody? Thanks. Now, people hate matrices because you don't see the full usefulness of them. Number one. And number two, it takes practice before they become easier. So matrices do make it easier to solve systems of equations. End of story. They do. It's just that they're new, they're freaky, and you don't even see. They really would eat up like, you know, so I have 2 unknowns, I need 2 equations. So the work is tied on that. It's the same amount of work either way. 3 unknowns, 3 equations, matrices kick by hand's ass. 4 equations, 4 unknowns, hell no, I'm not going to do this by hand. I'm going to do it in a matrix. 20 by 20, 20 equations, 20 letters. Holy shit. I'm going to put it in a matrix and let the matrix eat it up. It just eats it up. It's just so much quicker. But for you guys, you never see the full usefulness because thank God we don't do a 20 variable system of equations in here. I don't want to. But that's where you see the matrix is like super quick compared to trying to... Can you imagine doing 20 variables and 20 equations by hand? Holy shit. The bookkeeping required for that. And if I'm cussing too much, I'm sorry. What I used to say is if I'm offending you, then just wait a few minutes, I'll do it again.